Hi guys, in this video we are going to discuss the problem of the day from Geeks for Geeks on 8th of January. The problem's name is absolute difference divisible by k. The problem states that given an array of integers of size n and an integer k, find all the pairs in the array whose absolute difference is divisible by k. Great. So that's a very simple problem, a small problem I must say. And the input provided us or the test cases, the number one test case is that n is equal to 3, so there are total of 3 elements, and the k over here means that all the pairs that we are going to find should be divisible by k. So let's say the first pair we choose is 3 7. So what's the absolute difference? So absolute difference of them is 4. 7 minus 3 is 4. Is 4 divisible by 4? Yes, it is. So that this is a valid pair. What about 7 and 11? So 11 minus 7 is 4. Is 4 divisible by 4? Yes, it is. So that's also valid pair. What about 11 and 3? So 11 minus 3 is 8, which is equal to 2 into 4. So yeah, it's divisible by 4. So that's also valid pair. So at the end we return 3 because we have 3 valid pairs. Now let's try to develop an algorithm for this. So what would be the naive algorithm, or the algorithm that's coming to your mind at the first like in a brute force manner? So what we can do is that we can traverse through all the elements. So I'll be traversing through all the elements of the array, and I'll be checking for all the elements inside this loop, all elements except the outer one. So let's say except I. I'll be checking that if I select I, so let's say this outer loop represents the ith element, the inner loop represents the jth element. So if absolute difference of j minus I or I minus j, whatever, absolute actually would remain the same, mod k is equal to 0, then I need to increment my answer. At the end I'll return my answer. Great. So in this case this algorithm is valid, would definitely work, but what's the time complexity? So the time complexity over here would be order of n square, because we have two loops, both order of n, one inside the other. So the outer loop runs for order of n, the inner loop also runs for order of n. In totality they gives us a time complexity of order of n square. Would this work? Let's see in the question. So in the question they have mentioned that the time complexity is order of n plus k. The expected time complexity is order of n plus k. So no, this is not going to work. Also the constraints are set such that order of n square would give us a TLE. So what is another solution? So this is not going to work, although the answer would have been valid, but it's going to give us a TLE and it's not the optimal approach. So let's make another observation. So what they're asking is that the absolute difference between a minus b, right, should be divisible by k, only then it's a valid pair. In other terms, what I can say is that a mod k minus b mod k is equal to 0, right? Or like a minus b mod k is equal to 0. You could have like derived this, and from this you can have said this thing. So yeah, exactly means the same thing, doesn't matter how you write it. What's next? What can I do with this thing? So for those of you who don't know what a mod means, so mod basically is like when I say a minus b mod k, what I mean is that if you divide a minus b by k, what's the number you will be having? So when you divide it, you will be having the remainder, right? So this is that remainder. So let's say I say 5 modulus 3. That basically means when I divide 5 with 3, what I would have it. So this would be the remainder I'll have, right? So 2 is the answer. So it basically means the remainder. It's just a fancy way of saying remainder. Cool. With that, let's move ahead. So what we have obtained over here is that a modulus m, or k, whatever we are calling it. So a modulus m, a modulus k minus b modulus k is equal to 0. That's what we want to find. Or in other terms, a modulus k is equal to b modulus k. Perfect. That's all we require. So what we can do is, instead of traversing through the entire loop, we can store the number of elements that have a similar modulus. So I can go from left to right in an array. I can keep storing the number of like the elements in a certain hash map. So let's say over here, since k is defined, let's say I take an array. Over here k is, let's say, 4, so the array would be like this. So it would be having 4 cells represented by 0 1 2 3. Now I'll be storing the elements or the count of the elements having a certain modulus. So let's say I had a element that had a modulus 1, so I'll store it over here. So I'll increment this. By storing, I just mean I'll increment the count. So initially they'll be having 0 count. When I'll increment, so you'll start having 1, 2 and all such counts. So whenever now in my loop I'll see another element that has a similar modulus, I'll check like the current element mod m would give me some value. Let's say it gives me 1. Then what I'll do is I'll increment my result by whatever was there in my mods. So let me call this array as mods. So whatever was there in my mods, I'll increment my rest by it simply. And I also increment my mods later on, because now this element would also be present in this location, so I'll increment mods as well. So that's it. It just requires 3-4 lines of code. It's pretty intuitive, I'll say. If you still have some doubt, like, definitely let me know, but I think it was one of the simplest questions Geek for Geeks has asked in I'll say a long time, and also it was pretty clear. So over here I'm doing the same thing. I'm taking a mods. So a mods actually is a vector. You can actually take a unordered map over here, but the only reason I prefer vectors over unordered maps whenever it's possible is that the constant lookup has a big factor. So for example, it's although in both the cases it would be constant. For example, if you are looking something up in an unordered map or a hash map, it would also take a constant time, and if you are looking it up in an array or a vector, it would also take a constant time, but the constant factor actually changes. So let's say it was 0.1 second in case of like, it won't be 0.1 second, but let's say it was 0.1 millisecond or nanosecond, whatever. So if it was 0.1 millisecond in case of array, it would be somewhat 0.2 or something something of that order. It would definitely be bigger than the array itself. So it's always better to take array whenever you can. So over here, since k was defined, it was possible for me to actually use an array instead of a hash map. So in scenarios where we don't know what our like value would be or how big our array could be, in those scenarios we always have to take, because we don't have an option, so we have to take a hash map or some other sort of data structure. Over here I can actually take a vector, so I'm taking a vector, then I'm initializing my result. Then what I'm doing is that I'm adding the mods arr modulus k, so that's the other elements that I've already seen to the left of it. Let me write it up. Other elements, not Potter. Other elements that I have seen to the left of it, having a similar mod value. So I'll add it up, right? The only reason I'm adding one LL over here is because, okay, so actually it wasn't even required because rest already is long, so it's not required. Cool. After that, what I'm doing is I'm incrementing the value of my modes, because now in the same like when I'll move to the right of it, so let's say another element comes with same mod comes, then in that case it can actually use this particular element, that is the array I over here, to make a pair with it, because both of them have the same modulus. So that's why I'm incrementing it. Finally, I'm returning my result variable. Let's test it up. Cool enough. Yep, it works. So yeah, that's it for the video. It was really a simple question. I don't think a lot of you would have doubts in it, but still, if you do, let me know in the comment section below. I'll be more than happy to help you out. Thanks a lot, guys.